Good morning, dear, and welcome back. So, we have started watching video lecture on Introduction to Machine Learning, and today I am going to introduce you with a very important classification tool called Artificial Neural Network. So, we'll be discussing that how from the inspiration from how our brain works from there, how the concept of neuron, artificial neuron came, and then what was the power of a single neuron known as perceptron, that neuron as a computing element, what was the power, and then we'll talk about great perceptron from historical perspective, and then how multi-layer neural network was developed, and how to train a multi-layer neural network, and then how to accelerate training in a multi-layer neural network. Then we'll talk about a recurrent neural network kind of, perhaps the first recurrent neural network, that is the Hopfield network. Then also we'll discuss about bidirectional associative memory, and then self-organizing neural networks. So all this we'll study one by one, but first a little bit history. Okay, as you know, all our learning, information processing, and decision making takes place mostly in our central nervous system, that is the brain. Okay, and it learns. This is an example of a brain. This is cerebellum, this is cerebral cortex, and you can see different parts of the brain are responsible for learning different things. For example, this part learns language, some parts learn speech, some parts mail, and some part learn about hearing. Then motor action, whatever we do, for example, something is pinching here, I take some action. So these are called motor action. These are this part of the brain is responsible. So all this learning activities is taking care of this brain. But what is there inside? So inside you have densely packed neurons, that nerve cell, which is capable of computing, of course not digital computing, capable of learning through computation several patterns. Okay, and how many such neurons, the nerve cell, are there? uh, 80, somewhere 80 to 100 billions of neurons are there. Not only that, we have a tremendous networking, some 60 trillion network. So this is what is there in our brain, which learns many complicated things, gathering sensory information from the environment. So the AI people was greatly inspired and wanted to develop something like human brain like structure. Okay, and so this is an example. This is a typical neuron, this nerve cell, that is perhaps one of the biggest cell in our body. Okay, it has several parts, action. Action is just like the output. So this is soma, that is cell body, and these are the dendrite, that is input, and this is synapse. So inputs are associated with synapse, similar to weight. Okay, so and then the output is connected. So this is one, say, neuron, output of which is connected with another neuron. Okay, so this is another neuron. Okay, and several such neurons are interconnected. So this is the network. So the massive uh, infrastructure, computing infrastructure we have, perhaps which is making us able to think, to perceive, to learn many complicated activities and plan all kind of thing, right? So scientists were inspired vaguely though, but wanted to develop a computing element like this. You see, these are suppose our input x0, x1, x2 to xn, and these are actually, if you just see lecture number 9, these are nothing but features, okay, and they are all associated with some weight like synapse, right? So these are inputs with associated with weight, and this is a junction block, a summation block, and this weight of course is actually known as bias. Normally x0 is given -1 value. So here, so all this x1 w1 plus x2 in the w2 x2 plus w3 x3 plus wn xn minus w0. This is what computation is going on here, and then that is fed to a transfer function. So you see, input fed to a transfer function giving you the output. So it is actually inspired from the electrical engineers control theory, that output in input transform to output through a transfer function. So that is what Maculo-Pitts model is of neuron, which was developed in 1943. Okay, so we will talk about this. In 1943, Warren Maculo and Walter Pitts proposed a very simple idea that is still the basic basic of most artificial neural networks. That's a neuron. Okay. Now neuron was there, but there was no learning algorithm till structural learning algorithm till 1958, when Frank Rosenblatt introduced a training algorithm known as Perceptron Learning algorithm. It's very famous learning algorithm which could classify linearly separable tasks. And how? Very simple, right? You see, so randomly you select some weight, right? And you should have label data. Say, suppose I am trying uh, to learn this pattern and pattern. This on my input, this and pattern, right? Output is 1. So this is my and pattern, and I want my uh, neuron should be trained with this data label. These are called label data, by the way. So each row you read, row after row you read, and use this data for training. This is called training. What is the meaning of the training? You see, you randomly select W and then feed this inputs, right? This is fictitious input -1. So feed this input 0, 0. For example, there are two inputs, and output should have been 0, but you may have something because of bias, some output. So that will be error, right? So let the calculated error, EP means error is the pth epoch, right? Which is equals to desired value of the paired epoch minus actual value. So you could calculate errors because you have a level data, okay? And in an iterative way, you could try to make error towards 0, and in doing so, whatever W you will get, those will be the trained or the trained W parameters, and you can use after training to predict something. For example, if this is and so after training, what will happen? Some kind of decision boundary. So this is our AND, for example. So this is high corresponding to this, and all other are low. So you needed a decision boundary like this. That is given by this equals to 0. So after training, so throughout the training, you are trying to fix up the decision boundary. Okay, that is, you are trying to figure out W1, W2. Right? So this is all very simple classification task that Perceptron actually tries to do. Uh, Randomly selecting some weights, and then what I discussed, and then they tried several activation functions. They means I am talking about 1958's Frank Rosenblatt having very limited computers, right? Computing power. He tried several transfer function called activation function, also state. That means if x is positive, then you have y output +1. If x is negative, then output is 0. Sine function, if you have x positive greater than equal to 0, then output will be positive. If x is actually negative, then output will be -1. Then this is sigmoid function, then linear function. Of course, nowadays many more transfer functions are there, like ReLU, rectified linear unit and all. But we are talking about the historical developments, right? So these are the transfer function he tried, and it turns out that best result he obtained from this. So he settled with this transfer function called Hall limit or sine transfer function. Okay, and this is how perceptron learning algorithm works. So Wi p plus 1, that is in p plus 1th epoch, the weight Wi means it is the weight associated assigned to feature xi equals to WIP means earlier W plus alpha learning rate. Normally it is taken as 0.01, but at the time you did not have much computing power, so zero point 0.1 they took. Okay, and then xi times error, right? This is perhaps you have seen somewhere where lecture number 9. So this is similar to our gradient descent algorithm. Okay, so this is called delta learning rule because we are defining delta learning. Delta W means with how much W the new W will be compensated. Uh, Actually will be depending on the sign of this delta W. If delta W is positive, then weight has to be increased. So where it will happen? See, we have defined error, right? Equals to, now say if my actual output is less than desired output, then what one should do? One should actually increase the weight because I need to go to the desired value YD, right? And if my actual output is more than this, that means error is negative, then automatically the as a compensation error will be deducted. And that's how iteration after iteration, sometimes positive, sometimes negative, this will settle down when this will tends towards 0. So that's what algorithm is doing. So you are selecting randomly initial values Wi, then you are selecting some fictitious input -1, okay, and then you are passing through all these W parameter to activation function, okay, and then weight training you are doing. So this is called training, okay, this entire process, the training, okay. So it is called delta learning rule, and this is the perceptron training algorithm. And when this becomes 0, then you can infer that training is over. Now, whatever W you are getting, you can get a decision boundary like this if it is AND logic. And logic means you see several such pattern is there. say this is my low value corresponding, right? And these are my high value corresponding pattern. So through perceptual learning, you could get a decision boundary. So that is called classification, right? So that uh, algorithm, when it was developed in during 1958 to 60, when computation power was very, very limited, right? And um, uh, so using only one neuron, you could train the neuron using perceptron learning rule, and you could classify linearly separable problem. And all kind of linearly separable problem can be classified using this learning algorithm. So you can, as a assignment, you can do to input and, NAND, NOR, or all kind of pattern. You can train a perceptron to classify this pattern. But you see, when the task was not linearly separable, for example, exclusive OR like pattern, this this strategy failed. The single perceptron could not separate the non-linearly separable problem. And what happened, during those time, the competition was not there, and then people thought, so-called classical AI people thought that this is a data-driven system. They used to call it connectionist model, okay, where you do not have much enriched theory, do not have problem solving, deduction, all kind of thing. So, and they thought that it can only solve some simple problem, and then this activities in the area of neural network was suppressed, and it also went to the winter together with AI itself. But in 1980s again, when computation power was much more developed, and the concept of not using a single neuron, but concept of instead using a neural network, you know, structure like this. You see, so this is a neural network now, and using this kind of network architecture, they could solve this kind of non-linearly separable problem. The decision boundary were drawn, um, okay, using the network. But this network wanted to uh, have a learning algorithm, and you are right that uh, neural network training algorithm was developed during 1980s, and that algorithm is known as backpropagation algorithm. So which we are going to study next, but it is extremely important to know that for several years, because of the computation power, backpropagation algorithm requires a lot of computation. So because it was not there, great idea like perceptron learning algorithm were suppressed. This thing you should know that many things, many great invention um, achieve the similar kind of fate. But you see, almost all the today's learning algorithm minus computer, if you take the logic was developed much earlier in 1950s in the form of perceptron learning rule. So that's why I wanted to tell you that to give you a historical perspective of um, a great perceptron learning rule, which is known as delta learning rule, which could solve all linearly classify linearly separable problem. Solve means it could classify linearly separable problem. But after so many years, thanks to computation power which we achieved, we um developed a network, again inspired by our um, brain, human brain. You see, we could develop a networking like this. Then only many real world problems, including the um, non-linearly separable problem, could be classified using neural network. And that was the beginning, you know. Uh, there was a great surge of newer algorithm development once the backpropagation algorithm was developed, how to make it more faster, and how to make it bigger network. As the computation power grows, then the network structure also grew, and it could solve higher degree of nonlinearity inside a problem, and it started getting so many important issues solved, like speech recognition problem solved, like speech, text, everything. Means today vision, all kind of problem are being solved with gigantic neural network. Mm. So that's a very interesting story that we'll also discuss. But today we are to give you a glimpse of um, what happened in 1960s, and from today's perspective, we can see how relevant that was and how great idea those uh, those guys had. And that's why perceptron learning, although we are not using today that kind of transfer function, uh, why we are not using, I will tell you again. So that's a great development, right? So what you see here is I am encircling by one circle, because whenever in the neural network you will see this kind of structure, right? All computing element has this kind of structure. Okay, so inside this small circle, this computation is going on, right? There is summation minus threshold, passing it to some transfer function and giving you the output. Okay, so and if you have training data, that is level data, that is known input output set, if you have, you can use that using perceptron delta learning rule to train this neuron, that is to adjust this value W1, W2, W3. And once it is done, then if you just, for example, if your sensor instead of 00 gives some value like 0.01 x1, and then x2 some 0.02, still output will be 0. You can check it, okay? Or maybe 0.02, and then this is not 1.0.99 or 97, depending on this transfer function's ability. You will get correct result. Okay, correct result. So you will be checking that. So as an assignment, you start implementing it. Simple algorithm data learning rule, right? So and you solve and NAND or NOR, all this linear pattern classification task you can achieve just by training a single perceptron. Okay. So with this, I wanted to give you a glimpse of historical development of neuron and then neural network. We will study in the next class. Till then, have a nice day. Stay safe. Bye bye.